Welcome, fellow explorers, to a cosmic journey through the fascinating world of artificial intelligence. Now, when we talk about AI, we're not talking about some science fiction fantasy of sentient robots taking over the world, though that's a conversation for another time. No, instead, we're about to dive deep into the real world science, the algorithms, the code that's driving one of the most transformative technologies of our time. Over the next 15 chapters, we'll unravel the mysteries of AI from its humble beginnings to its potential to revolutionize countless industries. We'll explore the intricacies of machine learning, the power of large language models like ChatGPT, and the innovations from pioneers like OpenAI and Google Gemini. This is a technical deep dive, so get ready to challenge your assumptions and expand your understanding of what AI truly is and what it can achieve. Let's begin our exploration. The dream of creating artificial beings capable of thought has captivated humanity for centuries. Long before the invention of the computer, myths and stories explored the idea of artificial humans, from the ancient Greek myth of Pygmalion to Mary Shelley's Frankenstein. These stories, while fantastical, reflect a fundamental human desire to understand and perhaps even replicate the very essence of our own intelligence. But it wasn't until the mid-20th century, with the birth of modern computers, that the pursuit of artificial intelligence transformed from philosophical musings into a tangible scientific field. In 1950, British mathematician Alan Turing proposed a test, now known as the Turing test, to assess a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. This marked a pivotal moment, shifting the focus from simply defining AI to actually measuring its capabilities. Fast forward to today, and we see the rise of machine learning and large language models, or LLMs, which have revolutionized the field. Innovations like OpenAI's ChatGPT and Google's Gemini project are pushing the boundaries of what artificial intelligence can achieve, making it an integral part of our daily lives. Projects like DeepSeek are exploring new frontiers, demonstrating the vast potential and diverse applications of AI in various fields. Imagine, if you will, a child learning to ride a bicycle. They don't start with a complete understanding of physics or engineering. Instead, they learn through trial and error, through practice, through feedback from their environment. They fall, they get back up, they adjust their balance, and gradually they master the skill. This, in essence, is the heart of machine learning. Instead of explicitly programming machines with rules for every possible scenario, we feed them vast amounts of data and let them learn patterns and relationships on their own. Just as the child learns to ride by experiencing the act of riding, machines learn to perform tasks by analyzing data and identifying underlying structures. This data-driven approach has revolutionized the field of AI, enabling machines to achieve human-level performance or even surpass us in tasks that were once considered the exclusive domain of human intelligence. But how exactly do machines learn from data? Well, that's where the magic of algorithms comes in. Large language models like OpenAI's ChatGPT are prime examples of this learning process. Companies like OpenAI and Google are at the forefront, pushing the boundaries with innovations like DeepSeek and Google Gemini. These advancements are not just theoretical. They are transforming industries and redefining what's possible with AI. So, we've scratched the surface of machine learning, but what lies beneath? Picture this: a vast ocean of data. Traditional machine learning skims the surface, but deep learning, it plunges into the abyss. Deep learning takes inspiration from our own brains, mimicking the interconnected web of neurons. It's like comparing a bicycle to a spaceship. Both can get you from point A to B, but the spaceship tackles interstellar travel, pushing the boundaries of what's possible. Deep learning thrives on massive data sets, the kind that would make a supercomputer sweat. It's like the difference between reading a children's book and devouring the entire Library of Congress. With more data, deep learning models become more sophisticated, capable of uncovering hidden patterns and insights. This ability to learn complex patterns allows deep learning to tackle tasks that leave traditional machine learning algorithms in the dust. Image recognition, natural language processing, even composing music. Deep learning is transforming how we interact with the world and pushing the boundaries of artificial intelligence. Take ChatGPT, for example. Developed by OpenAI, it leverages deep learning to generate human-like text, revolutionizing how we communicate with machines. And then there's Google Gemini, pushing the envelope in AI research and applications. Tools like DeepSeek are enabling us to dive even deeper into data, uncovering insights that were previously unimaginable. Large language models, or LLMs, are at the forefront of this revolution, driving advancements in natural language understanding and generation. As we continue to explore the depths of AI, the possibilities are endless, and the journey has only just begun. Now, let's zoom in even further and explore the building blocks of deep learning neural networks. These intricate structures are inspired by the very organ that allows us to comprehend the universe, the human brain. Just like our brains have billions of interconnected neurons, artificial neural networks consist of layers upon layers of interconnected nodes. Each node receives input from other nodes, performs a simple calculation, and then passes the output to the next layer. It's like a cosmic dance of information flowing through the network. But what makes these networks so powerful? It's the connections between the nodes, each assigned a weight. These weights determine the strength of the connection and influence the output of the network. During training, the network adjusts these weights, constantly refining its understanding of the data. Think of it like learning to ride a bike. At first, your brain's neural connections are weak, resulting in wobbly movements. But with practice, the connections strengthen, leading to a smoother, more balanced ride. Similarly, neural networks fine-tune their connections as they learn from the data, improving their accuracy over time. Large language models like ChatGPT are prime examples of how these neural networks can be applied to understand and generate human-like text. Developed by organizations like OpenAI, these models are pushing the boundaries of what's possible with AI. Similarly, Google's Gemini project is another leap forward in the field of artificial intelligence. And with tools like DeepSeek, we are able to delve deeper into data, uncovering insights that were previously hidden. Machine learning, the broader field encompassing these technologies, continues to evolve, driving innovation across various domains. For millennia, language has been the hallmark of human communication, a complex tapestry of words, grammar, and context. Now, imagine if machines could understand and generate human language. breaking down the barriers between us and the digital world. That's the ambitious goal of natural language processing, or NLP. NLP sits at the intersection of computer science, artificial intelligence, and linguistics. It's like teaching a computer to read, write, and understand language, not just process it as a series of symbols. It's about deciphering the meaning behind the words, the nuances of tone, and the unspoken rules of conversation. Think about the voice assistants we interact with daily. They can understand our requests, respond in a conversational manner, and even tell jokes, some funnier than others, I might add. That's NLP in action, bridging the gap between human communication and machine understanding. Large language models like OpenAI's ChatGPT are at the forefront of this revolution. Companies like Google are also pushing the boundaries with innovations like Google Gemini. Machine learning is the backbone of these advancements, enabling systems to learn and improve from data. Tools like DeepSeek are enhancing our ability to analyze and interpret vast amounts of information. Together, these technologies are transforming how we interact with machines, making communication more seamless and intuitive. Welcome back, explorers. In this chapter, we are shifting our focus to the fascinating realm of computer vision and its intersection with other AI technologies. Just as our eyes capture light and send signals to our brains to interpret the world around us, computer vision aims to replicate this process digitally. Think about it. Every image, every video you see is just a collection of pixels, tiny dots of color. Computer vision algorithms have to decipher the meaning behind those pixels, to recognize patterns, shapes, and even emotions. It's like teaching a machine to see, not with biological eyes, but with algorithms and data. This is where machine learning and large language models like ChatGPT come into play. Through techniques like image classification, object detection, and image segmentation, computers can now identify objects, track movements, and even reconstruct three-dimensional scenes from two-dimensional images. From self-driving cars navigating complex environments to medical imaging systems detecting diseases, computer vision is pushing the boundaries of what machines can perceive and understand about our visual world. Innovations from OpenAI, Google Gemini, and DeepSeek are at the forefront of these advancements. When we talk about artificial intelligence, it's easy to conjure up images of humanoid robots taking over the world. But the reality of AI in robotics is far more nuanced and, dare I say, more exciting than science fiction. Robotics, at its core, is about creating machines that can perform tasks in the real world. These tasks can range from the mundane, like vacuuming a floor, to the incredibly complex, like performing surgery. AI comes into play by providing these robots with the intelligence needed to operate autonomously, to adapt to changing environments, and to learn from their experiences. Think of it this way: robotics provides the brawn, while AI provides the brains. Together, they form a powerful synergy that is poised to revolutionize industries, enhance productivity, and reshape the way we live and work. Beyond robotics, AI technologies like machine learning, large language models, LLMs such as ChatGPT, and innovations from OpenAI and Google Gemini are pushing the boundaries of what's possible. These advancements are not just theoretical. They are being applied in real-world scenarios, from DeepSeek's data analysis to enhancing everyday interactions. The future of AI is more than just robots. It's an integrated approach that combines various technologies to create smarter, more efficient systems. From the moment we're born, our health becomes a paramount concern. And in the 21st century, the field of healthcare is undergoing a profound transformation, fueled by the remarkable power of artificial intelligence. We're not just talking about incremental advancements here, but a fundamental shift in the way we diagnose, treat, and manage diseases. AI, including technologies like machine learning, LLMs, and platforms such as ChatGPT and DeepSeek, is revolutionizing medicine, offering the potential to improve patient outcomes, increase efficiency, and reduce healthcare costs. Imagine a world where algorithms from OpenAI or Google Gemini can analyze vast amounts of medical data to identify patterns and predict diseases before they even manifest symptoms. Or picture AI-powered assistants helping doctors make faster and more accurate diagnoses, freeing up their time to focus on patient care. Welcome back, fellow explorers. We're about to delve into the fascinating world of finance, a field where numbers reign supreme. You might not think of Wall Street as a hotbed of cutting-edge technology, but let me tell you, the financial industry has been quick to adopt AI, and for good reason. Think about it. At its core, finance is all about data. Mountains of data, constantly flowing, fluctuating, and informing the decisions of traders and investors around the world. AI, with its ability to analyze vast data sets and identify patterns, is a natural fit for this environment. One of the most prominent applications of AI in finance is in algorithmic trading. These aren't your grandfather's stockbrokers, folks. These are sophisticated algorithms trained on historical market data that can execute trades at lightning speed, far faster than any human ever could. And it's not just about speed. These algorithms can also identify subtle patterns and anomalies in the market that might escape even the most seasoned human trader. This allows them to make predictions about future market movements, giving them a significant edge in the high-stakes world of finance. Large language models like ChatGPT from OpenAI are also making waves in finance. Machine learning, a subset of AI, is crucial for developing these sophisticated trading algorithms. Companies like Google, with their Gemini project, are pushing the boundaries of what's possible with AI in finance. DeepSeek is another example, using AI to provide deeper insights into market trends and anomalies. The integration of AI in finance is not just a trend, it's a revolution, transforming how we understand and interact with the market. As we venture deeper into the realm of artificial intelligence, we inevitably encounter a critical crossroads, the intersection of technology and ethics. This juncture is not just a theoretical debate confined to academic circles, it is a pressing issue that affects every aspect of our daily lives. From the way we communicate and work to how we make decisions and solve problems, AI is becoming an integral part of our existence. But with this integration comes a host of ethical dilemmas that we must address head-on. It's one thing to build machines that can outperform us in complex games or analyze data with superhuman speed. These achievements are undoubtedly impressive and have pushed the boundaries of what we thought was possible. However, the true challenge lies not in the creation of these intelligent systems, but in how we choose to use them. The capabilities of AI including advanced models like large language models, LLMs, such as ChatGPT by OpenAI and Google Gemini, are expanding at an unprecedented rate. With this growth comes the responsibility to ensure that these technologies are used ethically and responsibly. But as we grant these machines more autonomy, as we entrust them with decisions that impact our lives in profound ways, we must confront a fundamental question. Just because we can, does it mean we should? This question is at the heart of the ethical debate surrounding AI. It forces us to consider the potential consequences of our actions and to weigh the benefits against the risks. The decisions we make today will shape the future of AI and its role in society, and it is crucial that we approach this responsibility with care and consideration. The ethical dilemmas posed by AI are numerous and complex. They span a wide range of issues, from privacy and security to fairness and accountability. Each of these issues presents its own set of challenges and requires careful thought and consideration. For example, how do we ensure that AI systems respect our privacy and protect our personal data? How do we prevent these systems from being used for malicious purposes, such as surveillance or cyber attacks? And how do we hold AI systems accountable for their actions, especially when they operate autonomously and make decisions without human intervention? One of the most pressing concerns is the potential for bias. Bias in AI can manifest in many ways, from the data used to train the systems to the algorithms themselves. If not addressed, these biases can lead to unfair and discriminatory outcomes, perpetuating existing inequalities and creating new ones. This is particularly concerning in areas such as hiring, lending, and law enforcement, where biased AI systems can have a significant impact on people's lives and livelihoods. AI systems, including those used in machine learning and deep learning applications like DeepSeek, are trained on massive datasets. If those datasets reflect existing societal biases, the AI will inherit and perpetuate those biases, potentially leading to unfair or discriminatory outcomes. This is a well-documented issue, and researchers and practitioners are working hard to develop methods to mitigate bias in AI. However, this is not a simple task. It requires a deep understanding of the sources of bias and the ways in which they can be addressed. It also requires ongoing vigilance and a commitment to fairness and equity. Imagine, for instance, an AI system used in hiring decisions that was trained on a dataset of predominantly male candidates in leadership positions. This system might unfairly penalize female candidates even if they possess all the necessary qualifications. This is not just a hypothetical scenario. It is a real issue that has been documented in several studies. The consequences of such bias can be far-reaching, affecting not only the individuals who are unfairly treated, but also the organizations that miss out on talented candidates. This system might unfairly penalize female candidates, even if they possess all the necessary qualifications. The impact of such bias can be profound, leading to a lack of diversity in the workplace and perpetuating existing gender inequalities. It can also undermine trust in AI systems and erode public confidence in their fairness and reliability. Addressing this issue requires a concerted effort to ensure that AI systems are trained on diverse and representative datasets, and that they are designed to be fair and unbiased. The challenge then is to develop AI systems that are not only intelligent but also fair, unbiased, and accountable for their decisions. This is no small feat. It requires a multidisciplinary approach, bringing together experts from fields such as computer science, ethics, law, and social sciences. It also requires collaboration between industry, academia, and government to develop standards and guidelines for the ethical use of AI. Transparency and accountability are key to building trust in AI systems and ensuring that they are used responsibly. It's a tall order, but one that we must strive to fulfill if we want to create a future where AI benefits all of humanity. The potential of AI is immense, and it has the power to transform our world in ways we can only begin to imagine. But with this power comes responsibility. We must ensure that AI is developed and used in ways that are ethical, fair, and just. By doing so, we can harness the power of AI to create a better future for all. As we've explored the vast capabilities of AI, one thing has become abundantly clear. This technology thrives on data. Data is the lifeblood of artificial intelligence, the essential fuel that powers its algorithms and enables it to perform tasks that were once the exclusive domain of human intelligence. From recognizing faces in a crowd to predicting the weather, AI's prowess is directly tied to the quantity and quality of the data it consumes. Like a cosmic entity drawing energy from a star, AI feeds on vast datasets to learn, adapt, and evolve. The more data it ingests, the more nuanced and sophisticated its understanding becomes. This process of learning from data is akin to how humans learn from experience, but on a scale and at a speed that far surpasses our natural capabilities. Imagine an AI system that can analyze millions of medical records in seconds, identifying patterns and correlations that would take human researchers years to uncover. But this insatiable appetite for data presents us with a critical challenge. How do we balance the undeniable benefits of AI with the fundamental right to privacy in an increasingly data-driven world? As AI systems become more integrated into our daily lives, they collect and analyze vast amounts of personal information. This data can be used to improve services, enhance user experiences, and drive innovation. However, it also raises significant concerns about how this information is stored, shared, and protected. The more data we feed AI systems, the more accurate and effective they become. This is because AI algorithms rely on large data sets to identify patterns, make predictions, and improve their performance over time. For example, an AI system designed to detect fraudulent transactions needs access to a vast amount of financial data to learn what constitutes normal behavior and what might indicate fraud. Similarly, an AI-powered recommendation engine needs to analyze user preferences and behaviors to provide personalized suggestions. But this data often contains sensitive personal information, from our online browsing habits and financial transactions to our medical records and social interactions. This information can reveal intimate details about our lives, our preferences, and our behaviors. It can be used to build detailed profiles of individuals, which can then be used for targeted advertising, personalized services, and even surveillance. The potential for misuse of this data is a significant concern, especially when it comes to protecting our privacy and maintaining our autonomy. In the wrong hands, this information can be used for nefarious purposes, from identity theft and financial fraud to manipulation and discrimination. Cyber criminals can exploit vulnerabilities in data systems to steal personal information, which can then be used to commit various forms of fraud. Additionally, data can be used to manipulate individuals by targeting them with misleading information or exploiting their vulnerabilities. This can have serious consequences for individuals and society as a whole, undermining trust in digital systems and eroding the foundations of a free and open society. Protecting data privacy is not just about safeguarding our personal information. It's about preserving the very fabric of a free and open society. When individuals feel that their privacy is respected and protected, they are more likely to engage with digital services and participate in the digital economy. This, in turn, drives innovation and economic growth. However, when privacy is compromised, it can lead to a loss of trust and a reluctance to use digital services. This can stifle innovation and hinder the development of new technologies. When individuals feel confident that their data is secure and used responsibly, they're more likely to embrace technological advancements and participate fully in the digital world. This confidence is built on transparency, accountability, and robust data protection measures. Organizations that prioritize data privacy and security can build trust with their users, fostering a positive relationship that benefits both parties. This trust is essential for the continued growth and development of AI technologies, as it encourages individuals to share their data and contribute to the collective knowledge base. But when trust is eroded, when individuals feel like their every move is being tracked and analyzed, it can lead to a chilling effect, stifling innovation, and hindering the progress that AI promises. This erosion of trust can result from data breaches, misuse of personal information, or a lack of transparency about how data is collected and used. When people feel that their privacy is being violated, they may become hesitant to use digital services, share their data, or engage with new technologies. This can slow down the adoption of AI and limit its potential to drive positive change in society. To address these challenges, it is crucial to develop and implement robust data privacy regulations and ethical guidelines for AI development. These measures should aim to protect individuals' privacy while enabling the responsible use of data for innovation and progress. This requires a collaborative effort from governments, industry, and civil society to create a framework that balances the benefits of AI with the need to protect personal information. By fostering a culture of transparency, accountability, and ethical responsibility, we can ensure that AI technologies are developed and used in ways that respect individuals' rights and promote the common good. One approach to achieving this balance is to give individuals more control over their data. This can be done through privacy settings that allow users to decide what information they want to share and with whom. Additionally, organizations can implement data minimization practices, collecting only the data that is necessary for a specific purpose and ensuring that it is stored securely. By empowering individuals to take control of their data, we can build a more trustworthy and secure digital environment. Ultimately, the goal is to harness the power of AI to drive innovation and improve our lives while safeguarding our privacy and protecting our rights. This requires a commitment to ethical AI development and a recognition of the importance of data privacy. By working together, we can create a future where AI technologies are used responsibly and ethically, benefiting individuals and society as a whole. The journey to this future is complex and challenging, but it is one that we must undertake to ensure that the data-hungry piece of AI serves the greater good. Large language models, LLMs, like ChatGPT, developed by OpenAI, and Google's Gemini are prime examples of AI's data dependency. These models are trained on vast datasets, enabling them to understand and generate human-like text. DeepSeek, another innovative AI tool, leverages machine learning to delve deep into data, uncovering insights that were previously hidden. These advancements highlight the incredible potential of AI when fueled by data, but they also underscore the importance of responsible data management and ethical AI development. From the depths of space to the streets of tomorrow, the universe of technology never ceases to amaze. And in this chapter, we are diving headfirst into the world of autonomous vehicles, where artificial intelligence is taking the wheel. Imagine a world where traffic jams become relics of the past, and commutes transform into opportunities to catch up on your favorite podcast. That's the promise of self-driving cars, a future where algorithms analyze sensor data in real time, making split-second decisions to navigate complex environments. But how do these metal marvels actually work? It's a symphony of sensors, data processing, and machine learning algorithms working in perfect harmony. Cameras, LiDAR, and radar act as the car's eyes, constantly scanning the surroundings and creating a detailed three-dimensional map of the environment. This data is then fed into the car's brain, a powerful computer system running sophisticated AI algorithms. These algorithms, trained on massive data sets of real-world driving scenarios, interpret the sensor data, identify obstacles, and make decisions about steering, acceleration, and braking. From the arcade cabinets of the past to the immersive virtual worlds of today, video games have always pushed the boundaries of technology. And behind the scenes, artificial intelligence has been quietly leveling up the gaming experience for decades. Think about those early arcade classics like Pac-Man or Space Invaders. The ghosts chasing you down weren't controlled by human players, but by simple AI algorithms that dictated their movements and strategies. Fast forward to today, and AI has evolved into a powerful tool that creates more realistic, challenging, and engaging gaming experiences. From non-player characters, or NPCs, that behave more realistically to procedurally generated game worlds that offer endless replayability, AI is transforming the way we play. But how does it all work? We often talk about personalized medicine, tailoring treatments to an individual's genetic makeup. This approach has revolutionized healthcare, allowing doctors to provide treatments that are specifically designed to work with a patient's unique genetic profile. By understanding the genetic factors that influence how a person responds to certain medications, doctors can prescribe treatments that are more effective and have fewer side effects. This level of personalization ensures that patients receive the best possible care, tailored to their individual needs. Well, what if we could do the same for education? Imagine a world where the educational experience is customized to fit each student's unique learning style, strengths, and weaknesses. Just as personalized medicine has transformed healthcare, personalized education has the potential to revolutionize the way we learn. By leveraging advanced technologies like artificial intelligence, we can create learning environments that adapt to the needs of each individual student, providing them with the support and resources they need to succeed. Imagine a world where learning is no longer a one-size-fits-all model. In traditional classrooms, students are often expected to learn at the same pace and in the same way, regardless of their individual differences. This can lead to some students feeling left behind, while others may become bored and disengaged. But with personalized education, we can create a more inclusive and effective learning environment. By using AI to analyze data on each student's performance, we can identify their strengths and weaknesses and tailor the learning experience to meet their specific needs. That's the promise of AI in education. With AI, we can analyze a student's strengths, weaknesses, and learning patterns. This technology allows us to gather detailed information on how each student learns best and use that information to create customized learning paths. By understanding the unique needs of each student, we can provide targeted support and challenges that help them reach their full potential. This level of personalization can make learning more engaging and effective, helping students to stay motivated and achieve their goals. With AI, we can analyze a student's strengths, weaknesses, and learning patterns. This data-driven approach allows us to create a more personalized and effective learning experience. By identifying the areas where a student needs extra help, we can provide targeted support that addresses their specific challenges. At the same time, we can also identify the areas where a student excels and provide them with advanced materials that keep them engaged and challenged. This balanced approach ensures that all students receive the support and resources they need to succeed. This allows us to create customized learning paths, providing targeted support and challenges precisely when needed. For example, a student who is struggling with algebra might receive extra practice problems that are tailored to their specific difficulties. These problems can be designed to address the areas where the student is having trouble, helping them to build their skills and confidence. At the same time, a student who excels in history might be given advanced materials that fuel their curiosity and deepen their understanding of the subject. This personalized approach ensures that all students are challenged and supported in ways that are meaningful to them. No more falling behind because the pace is too slow or feeling lost because it's too fast. With personalized education, each student can learn at their own pace, ensuring that they fully understand the material before moving on. This approach can help to reduce frustration and increase engagement, as students are able to learn in a way that works best for them. By providing targeted support and challenges, we can help all students to achieve their full potential, regardless of their starting point. Imagine a world where a student struggling with algebra receives extra practice problems tailored to their specific difficulties. These problems can be designed to address the areas where the student is having trouble, helping them to build their skills and confidence. At the same time, a student who excels in history might be given advanced materials that fuel their curiosity and deepen their understanding of the subject. This personalized approach ensures that all students are challenged and supported in ways that are meaningful to them. At the same time, another student who excels in history is presented with advanced materials that fuel their curiosity. This approach ensures that all students are challenged and supported in ways that are meaningful to them. By providing targeted support and challenges, we can help all students to achieve their full potential, regardless of their starting point. This level of personalization can make learning more engaging and effective, helping students to stay motivated and achieve their goals. It's like having a personal tutor available 24/7, guiding you through the vast universe of knowledge at your own pace. This level of support can make a huge difference in a student's learning experience, helping them to stay motivated and engaged. With AI-powered personalized education, students can receive the help they need when they need it, ensuring that they are always making progress. This approach can help to reduce frustration and increase engagement, as students are able to learn in a way that works best for them. This is the power of AI to unlock each student's full potential. By providing targeted support and challenges, we can help all students to achieve their full potential, regardless of their starting point. This level of personalization can make learning more engaging and effective, helping students to stay motivated and achieve their goals. With AI-powered personalized education, students can receive the help they need when they need it, ensuring that they are always making progress. And who knows, maybe someday, these AI tutors will be as cool as a holographic Yoda teaching you the ways of the Force. Imagine a future where students can learn from virtual tutors that are as engaging and inspiring as their favorite characters from movies and TV shows. This level of personalization and engagement can make learning more fun and effective, helping students to stay motivated and achieve their goals. With AI-powered personalized education, the possibilities are endless. But for now, let's focus on the incredible potential AI offers right here, right now. By leveraging advanced technologies like artificial intelligence, we can create learning environments that adapt to the needs of each individual student, providing them with the support and resources they need to succeed. This level of personalization can make learning more engaging and effective, helping students to stay motivated and achieve their goals. With AI-powered personalized education, the future of learning is bright. Predicting the future is a tricky business, especially when it comes to a field as complex and rapidly evolving as artificial intelligence. But just like we can use the laws of physics to predict the trajectory of a comet, we can use the current trends and advancements in AI to get a glimpse of what the future might hold. We are already seeing AI making its mark in various sectors, from healthcare to finance to transportation. But what we're witnessing now is just the tip of the iceberg. As AI systems become more sophisticated and integrated into our lives, their impact will only continue to grow. Imagine a world where AI helps us solve some of humanity's biggest challenges, like climate change, disease, and poverty. Imagine cities that run more efficiently thanks to intelligent traffic management systems, and buildings that adjust their energy consumption based on real-time data. These might sound like scenes from a science fiction film, but the building blocks for these technologies are being laid down right now. The future of AI is not just about creating smarter machines. It's about creating a smarter, more sustainable, and equitable future for everyone. From its humble beginnings to its current position at the forefront of technological innovation, artificial intelligence has come a long way. We've journeyed through the history of AI, explored its core concepts, and delved into its transformative impact on various industries. We've seen how AI is being used to personalize education, revolutionize healthcare, enhance our entertainment experiences, and even drive the cars of the future. But as remarkable as these advancements are, they merely scratch the surface of what AI might achieve in the years and decades to come. The future of AI is a vast and uncharted territory, filled with both incredible promise and potential pitfalls. It's a future that will be shaped by the decisions we make today, the ethical considerations we prioritize, and the creativity and ingenuity of the next generation of AI researchers and developers. So stay curious, stay informed, and stay engaged in the conversation about AI. Because the future, much like the universe itself, is full of endless possibilities, and it's up to us to explore them responsibly and ethically.